Welcome to day 2 of finding area of regular polygons. We're going to begin with question number 3. Depending on where I left off in your particular class period, you might be able to fast forward through some of this problem or all of this problem and move on to question number 4. Now, one of the first things that we talked about is on this problem, they gave us a radius. The very next thing we did was to draw in another radius to an adjoining or an adjacent vertex. Since the radii of a polygon are all congruent, this new radius would also have a measurement of 4. The next thing we did was find the measurement of the central angle in between the two radii with the vertex at the center. Because this is a pentagon, a 5-sided figure, the measurement of the central angle is 72 degrees. We do 360 degrees divided by the number of sides, which in this case is 5. So 360 divided by 5 is 72. The next thing we did was draw in the apothem, the line segment that goes from the center to a side of the polygon and makes a 90-degree angle when it reaches the side of that polygon. So now I've gone ahead and drawn in the apothem on our original figure over here, and I have also taken this smaller triangle, highlighted here in yellow, and drawn it off to the side over here so that we kind of have that blown up off to the side. The next thing we're going to do is find the measurement of the angle up here at the top of this small little triangle that is half of the original triangle from our original shape. The angle, the central angle on the larger triangle was 72 degrees, and the apothem is cutting that central angle in half. So we're going to take 72 degrees, we're going to divide that in half. So this angle up here is 36 degrees. And now we can use the information about the size of this angle and the length of the radius to find the length of the apothem and to find the length along the bottom right here that I've marked with an X. We're going to use that to find the side length of this pentagon, because that bottom portion right there, what I've marked with an X, and now I've marked it over here on this picture with a congruence mark, is exactly the same size as this little section. So if I can find X, then I can find the length of the entire side of the pentagon by taking the value for X and multiplying it by 2. In order to find those lengths, we're going to have to use SOHCAHTOA, right triangle trigonometry, that we learned several modules back. So the first value that we're going to find is this partial side length of our pentagon. We're going to find X. So we are standing up at that 36-degree angle. So I've gone ahead and labeled our sides now. We're standing up at this angle. Here's my little person. And so we have the hypotenuse, that is the radius of 4. We have the opposite side, that's X. That's the piece that we're going to find first. And then we have the adjacent side, which is the apothem. Now, if we want to find that opposite side, and the only other side that we know is the hypotenuse, we are going to have to use sine in order to do that. So I've gone ahead and set up our sine equation. We have sine of the angle where we're standing, 36 degrees, equals the opposite side, X, over our hypotenuse of 4. The next thing we need to do is to get rid of this 4 in our denominator. Since it's in the denominator, we're going to use multiplication to undo that. So I'm going to multiply both sides by 4. That will cancel this out. And then I'll pop this into my calculator. When I pop that into my calculator, I get a value of 2.351 when I take that out to 3 decimal places. So this segment over here on our original figure is 2.351. And the segment right next to it, which is exactly the same size, would also be 2.351. So putting that together from this corner here all the way to this corner over here then would be 4.702. So now we know the side length of every single side on this pentagon. 4.702, 4.702, 4.702, and 4.702. The next thing we need to do is find the apothem. So once again, we are going to use our trig functions. And just as a reminder, our adjacent side is our apothem. So I've gone ahead and labeled that right over here. Once again, we know our hypotenuse. That's that nice pretty number. We don't want to use the value that we just found. We always want to use the original work. So adjacent side and hypotenuse means we are going to be using cosine this time. So I've gone ahead and set up that cosine equation right down here. Cosine of the angle where we're standing, 36 degrees, is equal to the adjacent side, which is my apothem, divided by the hypotenuse, which is that radius of 4. So once again, we want to get rid of that denominator, so I'm going to need to multiply both sides by 4 to make that denominator cancel out. And then I will pop this into my calculator. And when I put that into my calculator, I get 3.236. So I've gone ahead and marked that on our little broken out triangle over here, but also on our original figure. I have 3.236 pointing to that apothem there. Now that we know the length of the side and the apothem, we can find the perimeter and the area of this figure. So we're going to go ahead and do the work for the perimeter and the area down at the bottom part of this screen. The perimeter is equal to the number of sides times the length of each of those sides. We have a 5-sided figure here, and then we figured out from our work using sine and then doubling that 4.702 is the length of that side. And so when I multiply those two together, we get a perimeter for this figure of 23.51. So there's our perimeter. And then to find our area, we need 1/2 times the length of the apothem times the perimeter. And we found our apothem using the sine function. That was 3.236. And we just calculated our perimeter as 23.51. So now we grab our calculators. We multiply 1/2 times 3.236 times 23.51, and we get an area of 38.039. No units on our perimeter or our area because our radius also did not have units. All right, moving on to question number 4. So question number 4 says we're going to sketch a regular octagon with a radius of 8.4 inches. Then we will find its perimeter and its area. All right, so I've gone ahead and drawn my regular octagon, and I've drawn in not just one radius of 8.4 inches, but I've gone ahead and drawn in the second radius as well. And then the next thing we are going to do is find the measure of this central angle, just like we did before. So an octagon has 8 sides, 360 degrees divided by 8 gives us 45 degrees. After that, we're going to draw in our apothem on the figure, and then we're going to draw that little right triangle off to the side. So I've gone ahead, I've drawn in the apothem right here on our octagon, and then this little triangle here that I've shaded in yellow for us. This little triangle right here is what we have blown up over here, drawn much bigger. I've gone ahead and marked where we're going to be standing on this triangle. We have the hypotenuse marked. We have our opposite side marked, which I went ahead and labeled that as X. Then we have our adjacent side, which is the apothem. We need to find the measurement of the angle where we're standing. That is going to be half of the measure of the central angle. Our central angle was 45 degrees, so we're going to take 45 and cut it in half. That gives us 22.5 degrees for that angle where we are standing. Then we want to find this opposite side. We know the hypotenuse, so once again, that means we're going to use the sine function to find that. So I've now set up that sine function. We have sine of the angle where we're standing, 22.5, is equal to the opposite side x divided by the hypotenuse, which is 8.4. Now, to find x, we're going to multiply both sides by the denominator. So multiply both sides by 8.4. And then we're going to take the sine of 22.5 and multiply it by 8.4 in our calculators. When I put that into my calculator, I got 3.215. Since the radius is being measured in inches, this would also be in inches. So I'm going to go ahead and label my opposite side here, 3.215. And that means that each one of these little segments over here on my original figure are 3.215. 3.215. So that means this side of the octagon is 6.43 inches. So every side on this regular octagon is 6.43 inches. Next, we need to find the measurement of the apothem. To find the measurement of the apothem, that is our adjacent side, we need to use the hypotenuse, which was that given value. So we're going to be using cosine. So now I've set up our cosine equation to find the apothem. Cosine of the angle where we're standing, 22.5 degrees, is equal to the adjacent side, which is our apothem, divided by the radius, which is 8.4, because that is our hypotenuse. So to find the length of the apothem, we're going to multiply both sides by 8.4, and then we're going to pop this into our calculator. So into your calculator, I want you to do 8.4 times the cosine of 22.5 degrees. When we pop that into our calculator, we get 7.761 inches for the apothem. So I've gone ahead and marked that on our zoomed in little triangle right here. And then I've also marked that on our original figure over here. We are all set up now to find the perimeter and the area of this regular octagon. So the perimeter is the number of sides. We have 8 sides on our octagon. So 8 times the length of one of those sides. We just figured out that one of those sides is 6.43 inches. So we take 8, we multiply it to 6.43, and we get a perimeter of 51.44 inches. And now we can use that information to find the area of our octagon. The area of the octagon is 1/2 the length of the apothem. That's what we found with our cosine equation. So that's that 7.761 times the perimeter, which we just calculated was 51.44. And then we multiply that together in our calculator. 1/2 times 7.761 times 51.44 comes out to be 199.613, and that would be inches squared. So that finishes up our second problem, problem number 4. We're going to go ahead and move on to problem number 5 next. So problem number 5 says we have a regular decagon, and it's drawn here for you. If you carefully count those sides, you will discover that a decagon has 10 sides. So our n value for this is 10, and it has a radius of 5.1 meters. Draw and label the radius, and then find the perimeter and the area. I would like you guys to go ahead and pause the video now. See if you can use the 2 previous examples to help you solve this problem, and then unpause the video to check your answers with mine. Welcome back. Let's go ahead and check your work against mine. So the first thing I did was add the radii. I didn't just draw in one radius, I drew in 2 so that we could get that nice little isosceles triangle there. And then I found the measurement of the central angle. Next thing we're going to do is draw in that apothem, and then draw a zoomed in version of that highlighted yellow triangle there. I've labeled my radius as 15.1 meters. We have the apothem there in blue, and half the side length down on the bottom in black. Now it's time to find the size of that angle. So the measurement of that angle up where we are standing, I've gone ahead and drawn my little guy in here, is half of the measurement of the central angle. Central angle is 36 degrees, so this angle here is 18 degrees. And now to find this opposite side here, we're going to use opposite and hypotenuse, so sine. So we have sine of 18 degrees equals our opposite side, x, over 15.1. When we multiply both sides by 15.1, we get a value for x of 4.666 meters. So that means that the bottom side, their x, 4.666 meters. We have two segments that same size that make up a side of the decagon. And so we have 9.332 meters for that side. Next, we need to find the length of the apothem. So our adjacent side and our hypotenuse, which means we are going to use the cosine function. So we have our equation all set up. Cosine of 18 degrees equals the adjacent side, the apothem, divided by the radius of 15.1. So we're going to multiply both sides by 15.1 to find our apothem. You should find that the apothem is 14.361 meters. So I've gone ahead and indicated that on our small little triangle, the broken out triangle, and then on our actual decagon here. So now it's time to find the perimeter and the area. There are 10 sides to a decagon, so we take 10 times the side length of 9.332. We get 93.32 meters for the perimeter. The area is 1/2 the apothem of 14.361 times the perimeter of 93.32 for a total area of 670.084 meters squared. All right, on to the last problem that we are going to cover for today, problem number 6. So problem number 6 says that we need to find the area and the perimeter of this regular polygon. Notice this time they gave us just a side length here, and we need to find the area and perimeter. This shape has 1, 2, 3, 4, 5, 6, 7 sides. So we actually have all of the information that we need to find the perimeter on this shape. No trig needed to find our perimeter. We have 7 sides times that side length of 11. And that means the perimeter for this figure is 77 yards. Now we need to go about finding the area. To find the area, we need the perimeter, and then we also need the apothem. They have the apothem drawn in for us here. And we are going to need to use some sine, cosine, and tangent in order to find the length of this apothem. So just like on all the other problems, I'm going to go ahead and draw in the radii that form the central angle between two vertices. So now I've drawn in those radii in red. We don't know how big they are, but we can find it if we need to using sine, cosine, and tangent. And then I have these little segments marked as congruent. We know that this entire side here is 11 yards, which means that each one of these little sections up here is half of that. So this would be 5.5 yards, and over here would be another 5.5 yards. So now I've gone ahead and drawn our zoomed in triangle over here, and that is a right triangle formed by the apothem and that half of the side of our 7-sided polygon here. And then I went ahead and found the angle that we are standing at. We are up here. That's going to be half of the central angle, so half of 51.429 degrees, which is 25.715. Now, the only thing that we need about this in order to find the area is the apothem. So all we need is the adjacent side. We don't need the hypotenuse. We don't need the radius at all to solve this problem. We need that adjacent side, and we have the opposite side this time. So adjacent and opposite means we are going to use tangent this time around. So down here you can see I've set up our tangent equation. Tangent of the angle that we're standing at, 25.715, is equal to the opposite side, that's that 5.5 yards, over the apothem, that adjacent side. So once again, we need to multiply. We always multiply by the denominator of a fraction. So we're going to multiply both sides by the apothem. So when we multiply both sides by the apothem, it cancels out in my denominator on the right-hand side, but that just moves that entire thing now over to the left-hand side. So I've got the apothem times the tangent of 25.715. I want the apothem all by itself, so we need to divide both sides by the tangent of 25.715 degrees. And now we need to pop this into our calculator so that we can find the length of that apothem. And when I pop that into my calculator, I get 11.421 yards. So we need to use this along with our perimeter of 77 yards in order to find the area now. So I'm going to squeeze my work for the area over here underneath where we found the perimeter. The area is 1/2 times the apothem, which we just found is 11.421, times the perimeter that we found way back at the beginning of 77. And now we pop this into our calculator to get our final answer. And when I do that in my calculator, I get 709 yards squared. Don't forget the squared on that unit there. So there's my final answer. That finishes up everything that we need to cover for today. On Monday, we're going to put this information all together and use it to find areas of some very oddly shaped figures. If I've gone too fast at any point in this video for you, remember you can always slow me down. You can rewind and go back over any section of this video that you need to, and I'll be back on Monday to answer any questions you guys have. I hope you have a great weekend. Bye.